Thank you everybody for joining this morning, and I'm going to be talking through scaling performance and availability monitoring across distributed squads at Skyscanner. As a little introduction about myself, I've been an Android engineer for about 10 years now, which is quite scary. I first attended droidcon back in 2013, been attending I think pretty much every year since, but it's my first time presenting here, so very happy to be up on this stage rather than sitting down there. I joined Skyscanner at the beginning of 2020, which was a fantastic time to join a travel company because what could go wrong? So I had the 3 months of everything going great, followed by about 18 months of very interesting experiences. And I'm currently leading Skyscanner's internal mobile platform team, which means we actually build the tooling and build sort of functionality for other engineers and other teams within Skyscanner, which has been a really interesting challenge because that was an area that was actually completely new to me. Couple of my social media links as well. Will the Twitter one stay there after today? I don't know, but it's there for now. And just a little about Skyscanner as well to kind of set the context of what I'm talking about. So, it's a travel booking app for those of you who don't know. You can search for flights, hotels, car rental. And we have about 10 different mobile engineering teams. And one of the reasons for this as well, because I have been asked a question, why do we have so many teams, is I'd say the Skyscanner app actually has a lot of depth. It may look like it only has these sort of 3 different sections, but as you go through, you have very different requirements for flights, hotels, and cars, as you can imagine. Then you go through to things like taking payments, how do we render different airlines, and you actually find before long, we actually do need a lot of engineers. And so that's why a lot of the problems we talk about are how we actually scale this. We have distributed offices, particularly since COVID and the rise of remote working as well. We actually do have a lot of these challenges to solve. So what are we going to be specifically talking about today? Now, one of the questions that I feel like I've asked a lot and we get asked a lot is, how do we know the impact our changes are having on performance and availability? We want to ship a refactor, or we want to launch a new feature, or we want to change part of the screen. How do we know this? But then before this, we actually need to answer, well, how do we define this? What does availability and performance mean? So what we're going to be looking at today is how we think about defining these availability and performance metrics, and then giving sort of an overview of how we've implemented and scaled this on our mobile apps at Skyscanner, and sort of how we transform this data as well to make it clear, useful, and relevant. Now, this is actually something which has been a long journey. We've been working on for 2 to 3 years, and so there's a lot of information that should go through, a lot to get you thinking about it, get some ideas, some things that we've been going through, but almost each section of this could have been a talk on its own. So there's a couple of things I won't be talking about as well, just to set the expectations. It does have some Android code, because I'm a droidcon, I thought I had to include something, but it does focus, as I said, on this higher level approach. I was actually at 2 really, really great talks yesterday, by Diana Samboni and Ben Weiss, which I would recommend checking out, where I actually think complement this talk really, really well, where those 2 talks deal with this lower level, how you might want to put your Android code into action before looking at what we're speaking about here. And again, I would recommend once those recordings are available, if you weren't there yesterday, please go check those out. It will add probably some more context into this as well. The other question, will this talk tell me to integrate with this? Am I going to say, you need to use this data provider or this monitoring library? No, it's actually very agnostic, so you can take what I'm about to talk about. It's not a sales pitch, should apply to anything. So yeah, just think about that as we're going through as well. So we're going to start off with app availability. And again, the question is, what does it mean for an app to be available? Or maybe what's a not available app look like? Now, the one that everybody knows about is crashes. Lots of tools to track crashes. I'm pretty sure almost everybody sitting here has used one of them, or experienced crashes, or thought about how to monitor these, and so they're very easy to measure. But what we found is often you can fall into the trap of saying, okay, I have no crashes, my Google Play console is telling me I have 100% crash-free rate, Firebase is looking good, so the app is available, right? But then you end up with scenarios like this, where, okay, maybe you launch the app, it's all looking good, and then you get into the home screen and you just get an error message. And it's a blocking error message. You maybe get a try again button, you hit it, nothing's working, and you're just stuck in a loop. The user's completely blocked from doing anything. And, but it's not crashing, so the app's available. Your Google Play console might not be telling you if there's any problems. You could have to wait until you actually get social media complaints or customer service of people saying, oh, it's not working, and the default is, well, is it your network? And in a lot of cases, it's not. So we were facing problems around this Skyscanner, and how do we actually track these sort of errors? Now, we had a generic error analytics event, but this wasn't widely adopted. We had no standards in place. We said to squads, okay, you should be sending errors. But that was pretty much all the guidance we had. So there were no consistency in the values we were sending. Sometimes they'd be populated with stack traces, sometimes they'd be populated with descriptions, sometimes it would be very, very low-level detail, sometimes it would be high-level detail, like flights error. That means nothing. In other sense, you could get an exception at line 137 in this class, which again, even without context, also means not much to us. And we weren't really monitoring this in a central way. So squads would be able to say, maybe they would know how to track their errors. We even had cases where people would say, oh, I don't know where these errors go. I've never checked it. And obviously this isn't good. So how did we start to tackle this as Skyscanners? Now the first step may sound pretty simple, but it was actually just defining a simple error event. What do we want this to look like? Now we said, okay, we want a feature name, which is maybe the high level. Was this a flight search, a hotel search, or a car hire search? Obviously, I'll just be focusing on those at a very high level today, but you can think for each feature, this could be defined. You also want to have the component name, so within that, maybe the lower level, which component you need to look at. Description, again, just adding a little more information, and the stack trace, if applicable. So we did this to try and find the balance, because we want to get, and it's a very tricky balance to get, but getting that any engineer should be able to look at this data and understand where the problem is. But also, it should contain enough detail for those engineers who really do know the code to actually work out exactly where it is. So again, that balance between what's too high level and what's too low level. But then we also wanted to make sure that events should be self-contained, because I've been in a situation myself where it's very, very painful. You're in the middle of an incident, you're being told, we're getting these errors, we're getting this, look into what's happening, and it's like, okay, where can I get this information? It's in this table. Where can I get the IDs for this user? Oh, it's in another table. Oh, this is in this. And you're trying to write join queries in the middle of the night. No, that's not what you want to do. You just want to be able to query your data, understand, okay, here's my error event, this tells me what I need to know. But then we ran into the problem of, well, not all errors are equal. We had the example before where you go and you get a blocking screen, you try again button, that doesn't work. That's obviously really, really bad. But what if we had a case where the user's going through, say they're booking a flight, they've clicked through, they're choosing their provider, and then they get a forced reauthentication screen because something went wrong in our backend or locally on the app. Either we messed up the storage, so we lost their token, there was a problem with the backend response, and we're forcing them to relog in. Now, this isn't a good user experience. And if people really like their flights, they're really happy with it, they'll probably just hit login and vote continue. But there's a risk that they could say, I forgot my details, I don't know where I was logged in, this is too much effort, and they'll just exit out of the app. But then you have, say, an even lesser example, where, okay, you're looking for your flights, you found your perfect flights, you're clicking through, and then the images just aren't loading on the final screen. Again, maybe we messed up something with our cache, maybe the image server's not working, or we were malforming the response coming back. It's not probably, if you found these flights, it's very unlikely that you're going to say, hey, at this point, I'm not going to book anymore because I can't see the logo that I just saw, or I can't see the little nice image of my destination at the top. But we had the problem here is, how do we get engineers to agree? Because, you might look at this and it could be quite easy to understand, oh, okay, a forced authentication is probably worse than the images not loading. But maybe you're an engineer who's just worked on that final screen and you've put a lot of love and care into rewriting the image cache, getting everything working. Actually, for you, that could be really big. And you could say, nope, this is huge. We need to know about this. We need to track it. We need to be alerted. And again, we're sort of, how do you actually solve this problem? And we did this by actually taking a lot of time to go through centrally defined error severities. Now, we took a lot of inspiration. All the QR codes on the slides go to the links that I have for those who are interested. But this is actually syslog, which is very, very common. I can't even say we had to research it to find inspiration. It's almost the first thing that comes up when you search. But we actually used their definitions. So they have definitions for sort of critical versus an error versus warning versus info. But we actually put Skyscanner specific definitions on top of these. Now, for Skyscanner as a business, booking travel is our most important thing. It's how we make money. It's what people go to the app for. And therefore, anything that we know actually stops that booking flow completely is our highest priority. Anything less than that, okay, we can go through it. And we actually spend a lot of time writing up definitions, putting examples in place, and having this where every engineer knows when they're defining their errors, where they need to look so that we have this consistency. And this took a long time. Now, for you, this is where it's like you should be thinking of what's important for your app and actually thinking from a user's point of view. Maybe you're a banking app or a fintech app. It could be checking your balance and sending a transaction. You could say if a user's not able to check their balance, that's the most important thing to do. Or if they're not able to send a transaction, for example, obviously that's really, really important. So this is, when you need to start thinking from a user, what does it mean? Because often that can actually vary quite a lot from what you as an engineer might consider something that's unavailable. So now a little look into how we did this as well, sort of building the logger, showing you some Android code. It's actually very, very simple. So this is, still just a data class we put in where we just have the severity, the fields we did previously, and having this as an enum you can go through. And again, very, very simple, not much complexity. To be honest, I don't have anything to add because it's a Kotlin data class. It's pretty self-contained. And again, for the logger, we sort of introduced this operational event logger, which, you just simply has a very interface log error. And in the implementation, again, very simple. You can start routing this to wherever it needs to go. All you need to do is just do a mapping to whatever backend service you're using, whether this is sending it to Firebase, sending it to a data platform of your choice. Very, very simple, and you can also send it to multiple places. Now, we tried to make this really, really simple just to make sure engineers focus on the what they're sending rather than the how. We don't want thinking, oh, I don't know, do I have to inject this class or inject this class? I need this dependency. Oh, now I need to add it onto this module. It should just be simple, because if you don't make it simple, engineers just end up not doing it. Especially, as you said, when you've got different time zones, different teams working across it. If it's hard for them to do, it just doesn't work. And again, that sort of loses the consistency that we want to be going for. So we are going to be going back later on and looking at these events and how we use them and what we do with this information. But I'm now going to quickly move on to the second part. So we've covered at a high level availability. We're now going to be going through performance. We actually end up with a very similar set of questions. We say, okay, what should we be measuring? And the one that, again, been talked about a lot is app launch time. Okay, app launch time, yeah, it's a key indicator of performance. There's lots of articles out there that go into why it's important, how many users uninstall the app if it doesn't load in X amount of time, what sort of impact this can have on retention, or even first-time users. And we do measure this at Skyscanner, but to be honest, I could sit here and have an entire talk or multiple talks on how to actively track this. So instead, I would highly recommend checking out this blog from PY, well, it's his Twitter handle. He's a distinguished engineer at Block, and he's actually written a lot of really deep dive articles on how to effectively track this, how to understand this. So all I'm going to say is we do track this at Skyscanner. I'll go into how we use that in a bit. But for a deeper dive on that, please take a look, and you will be amazed at how complex it can actually be. But then we also have the page load time. That's, again, something that you can see in your vitals within the Google Play console, understanding that, okay, how long are your fragments or activities taking to render? And so again, that is important. But then you get into, well, what else? Google Play actually really just talks about, again, the technical side. How many dropped frames do you have? How much jank do you have? Again, Ben's talk yesterday went into a great overview of the tooling that can be used around here that Google are providing, the libraries you can use. But again, let's take this back to what the user could see. Now, we have an example. You have, okay, you've started the Skyscanner app. It's launched super quick. App launch time is great. The first page is loading great. Second page is loading great. You're going through to search for your flights. Everything is looking good. You hit search, and you end up with something like this. You just get loading for 30 seconds. Now, at this point, it could be maybe it really is the network call is taking a long time to come back. Maybe we're not dropping frames at all. Our coroutines are working really well. The user can still be scrolling. So maybe as an engineer, we could say, it's really performant. There's no drop frames. It's really looking good. But if you ask a user, oh, how's the app performing? I'm going to say, it sucks. I can't load my flights. Now, they don't care about any of that. And again, this was sort of the challenge that we were trying to understand, of thinking, well, how do we approach this, and how can we measure what actually matters on top of, as I said, sort of the technical side? And so we went into defining these meaningful measurements. And the one that we decided at Skyscanner is what we call TTFR, time to first result and time to last result, which is from the second a user clicks search, how long does it take to get back their first flight result, giving them something on the screen, and also the last result, because Skyscanner's backend system for loading flights is, again, insanely complex. It would be a whole talk of its own again, but we get back sort of different pages, and it's really important because the first flight might not necessarily be the flight that the user wants. So we just track both to understand how long does it take them to first get something they could click on versus the full flights where we know they're getting all the options. And this is, again, as I said, with availability, this is when you start thinking about what's important for your app. This could be a certain onboarding flow, or again, you take like a banking example, it could be how long does it actually take to send that transaction or view your balance from going in, hitting view, loading that back on the screen. Now, again, sort of a very quick look into how we tried to look at this code. Very, very similar. So quite a simple interface. This is a little simplified just to get it to fit on the screen and just give an overview of what we're talking about, but just some very, very simple methods where it's pretty explicit what it's saying. There's no hidden meanings, just saying when did your search start, first result, last result, and also the page load, which we'll look at in a second. And we tried to keep this kind of self-contained, and we actually did it this way where you just pass in a different name, because one of the other problems we found is we tried to be kind of clever at the beginning of saying, well, you can have a different logger per feature using dependency injection, and you set it up with a name and you pass it around. But we had the same, and we're actually running into problems from the engineering side of engineers either didn't know how to pass in the right logger. When you start using dependency injection, you start getting these problems of, oh, you somehow created two instances of the same logger with the same name, and so this field was actually being set in the first one and not the second one. So all of this stuff. So we actually said, you know what, we're actually just going to let you call the methods from wherever you want, which is also important because if you're really trying to get those most accurate measurements, we can actually be calling these at different points. For example, when the user clicked on the search button, might be on one class. When you actually get it back, maybe you want to do that in the view holder of a recycler view, just so you know exactly when that final render finished. You shouldn't be trying to put it all in one class just for the sake of it. You can also go into a little more detail. One of the other things we did, but it's making this slide too long if I added all the code, is even being able to break these down into the steps. So you might want to actually have a step within this where you have the high-level measurement, but you can understand how much time was the network code, how much time was passing that response, how much time was actually rendering the view on the screen, which again can then really help you identify these bottlenecks later on. Now, the page load is kind of interesting. I thought I'd just show this very quickly as an example of some of the things you can do, where we actually used some code like this, where we just have to pass in a fragment, and we take away the boilerplate as well. Using the lifecycle callbacks, it's very easy to actually register, provide this consistency, rather than relying on users having to, or our engineers in this case, having to manually instrument each page. Now, if you copy this, there's a lot more checks you have to add, different null checks, making sure the fragment is right, because the fragment manager can sometimes do crazy things and not return what you were expecting it to return. But again, sort of at a very high level, you can see how we get this consistency. Another gotcha, which just to call out again, sort of learnings we had from this process, was actually we tried to be too clever at first, where if you look on the screen, you can see we pass in two arguments, a fragment and a page name. And we actually wanted to say, well, what if we just pass the fragment and take out the class name? We can extract that, we can do it all with one thing. And this backfired because engineers didn't know. Again, talking about scaling this, you can't expect every engineer to automatically know the internals of every single class that, say, a platform team like my team is providing. And because they didn't know, we would be going through refactors and we would start seeing data breaking of, why did this fragment stop sending data on this day? What went wrong? And we'd look in the code, we couldn't find it. And it was because they refactored the name, they had, the class name, they had no idea the impact it would have. And so we actually decided to make this explicit, so then it's clear to engineers, it's clear to us, we can keep it across class name changes, etc. And that's why it's like trying to find this balance between, again, taking away as much boilerplate as you can versus making things explicit and obvious. Okay, so now we have some data. We've defined our availability metrics, and we've provided a sort of internal API. We've defined our performance metrics. You also put in some consistent naming, which is important to put as well. If you want to have something like flight search, you should make sure all your performance and availability events for one feature are sent the same so you can compare these. And we maybe get a table that looks like this. So we have one for availability, I'm sure one for performance in a second, which is just this for raw data you see, which is from a data provider of your choice. In Firebase, Google Play, however this is looking, you just start seeing this table. If you're using a library, you should also see a lot of auto-tagging of these events, which is really nice. So maybe the OS version, the device name, etc., which, again, depending on what you use. And these will count as what's called RUM events, real user monitoring, just to reference. So these aren't being generated by performance tests or a simulator. These are showing what the user's really experiencing at one time. And we look maybe the same for performance. We have the same, we just get the different ones coming through, app launch, page load, TTFR, and we can start visualizing this. So maybe we want to break this down by feature. We can see, okay, what are my errors per feature? Plot a little graph like this over time. Same for result and same for duration. And we can also start looking at, okay, maybe I'm a flight search engineer and I really want to understand. You can also slice this data in a different way to just look at the breakdown of your feature. Now, this is okay, so you can start seeing some information here. You can go, okay, I can understand how many warnings I'm getting, how many critical errors should I care about, what's the performance looking like. And so just to give sort of a recap of where we are at this point before I go into the second half of the talk. So we've defined what it's important to measure on availability and performance, so what matters for the user. For the availability, we have our clear severities and definitions set of what the expectation of what each severity means and how to send these through. For performance, again, what matters to the user, because this isn't just the number of job frames, even though that is important. And for the technical implementation, letting engineers focus on the what rather than the how. And again, this was particularly important when thinking of scaling this across squads. At Skyscanner, we have a lot of legacy code, which I'm sure some of you in the audience do too. And again, we just wanted to make this really easy, simple interface. Engineers just go, this makes sense. And what was really nice as well is then engineers start being able to share this information with each other. They don't have to always look through complex documentation, and it can kind of become an organic, people should be wanting to move to this logger rather than feeling like it's a chore to implement and do so just because they're told. But sometimes there can be problems with this raw data. What does good versus bad data look like? We looked at the previous graphs before. Maybe we saw, okay, one feature was higher than the other. Does this really matter? Should we care about it? What does it mean? Is that number of errors a good number of errors? Is it a bad number of errors? Who knows? So maybe if you're really detailed on the feature, you could understand, but we also often get cases where people from outside the team, or maybe you don't have as much context, can look and start either panicking and saying, what's happening? Why do we have this graph? Or maybe someone shouldn't be panicking when they should be panicking. And how do we actually solve this? So this is now sort of the second half, thinking about how we can actually use this data. So probably the slightly more interesting part, and this is talking about applying SRE, which stands for Site Reliability Engineering Principles. This was completely new to me before I joined Skyscanner. To be honest, before I joined Skyscanner, I worked in a company where we sent out the data from the app, and we had another team who looked after it. We actually didn't get involved as engineers at all. And because of that, I had no experience in this area. I knew sort of the basics of monitoring, what this meant, but nothing more than that. And there's a real key resource which I got introduced to, which is the Google SRE Handbook, which please take that link. The fact is I could talk about, well, I actually couldn't talk about it because it's such a huge subject, but people do. And there's even, in the last week, there's been literal SRE conferences going on. So I'm not going to try and explain all of it, look through the book. It has a great introduction. I'm going to pick out a couple of key quotes as an introduction in a second. But I'm going to focus on the one area which is really specific to our case here, which is around monitoring, and explain it sort of the way it was explained to me as a mobile engineer, how I started to understand it, and how I actually started applying this to the data that we have at Skyscanner. So this is a long quote, which I took from the introduction, just to read through, but sort of the most important part on SRE as an introduction is this second bit. And it's thinking of, as a software engineer, how would I want to invest my time to accomplish a set of repetitive tasks? In this case, it might be, it will be analyzing the data. You know, instead of keep on running these different queries to understand what the data means, how can we automate this? And it's, because I said, it's become this set of practices, a set of incentives on how to think about this. And I'm going to look at the one area, which is monitoring. Second quote, before we get into it, is this one, which is far easier to have a meaningful conversation about the reliability of a service when you have an objective way of measuring that. Now, we already started looking at this at the beginning. If you think of when I was talking about the error severity definitions, we were trying to provide these objective definitions internally of saying, what does a critical error versus just a warning mean? But we're actually going to look at how this applies when we're manipulating this data and understanding it. Now, there's three main terms, which I will go through. They're very similar, but they are different, and I will go through them, which are SLIs, SLOs, SLAs. Don't expect you to remember all of this. I still get them confused myself. I'll send a message, and someone will say, are you sure you meant SLI and not SLO? And I'll look at it, I'll go, yes, have to humble myself. But the way to look at it is taking a definition. We have SLI as your service level indicator. So this is the one that says this thing should be true. Then you have your objective, which is what portion of the time should that thing be true? And then the agreement, which is the or else. Now, SLAs, the service level agreements, I feel like people here have the most familiarity with, because in a lot of contracts you sign, you know, even with internet providers, it's the whole, you will get 99.9% uptime over the course of a year, or you'll get a refund on your bill, as an example. I took these definitions from a company called New Relic. I linked to their blog as well. They actually have a really great blog, which is an introduction to thinking of these terms. But to actually put them into what we've been talking about, we could maybe say for availability, sessions should not be experiencing a crash or critical error 99.5% of the time in a 1 hour period, or the engineer will be paged. We could then go into performance and say, well, our time to first result should take less than 3 seconds to load 90% of the time, or an alert will be sent on Slack. Maybe we don't want to page the engineer just for a drop in performance, but we still want to know about it. Very briefly, how do we calculate this data? Again, I'm just going to skip over this, but just to give an introduction onto how this sort of works, because it's the sort of thing that can seem quite complicated. How do we work out these values? But it's actually not that bad. So for availability, we go through, we just take our total number of sessions, we define critical errors as being the ones we care about with our definitions, add the number of critical errors plus crashes, those count as our unavailable sessions, do this maths, and we get out a number. So plugging some numbers in here, if we had 10,000 sessions, 100 critical errors, 50 crashes, this gives us a 98.5% adherence rate. The performance is actually slightly simpler. We just take a number of page loads, and then less than the SLI versus number of page loads in total. And again, plugging this in, and we end up with something like this. And we say, okay, we have 95.5%. Now, how do we generate this data? As I said, I could probably give a deep dive talk onto every single section I've talked about today, but it really depends on your infrastructure. At Skyscanner, we actually started this by actually just having a very simple Python batch job, which would take the data from the original data. It would just run these queries against it each hour, and it would actually just store it as a CSV file, the sort of format which I'll show you in a second. Now, there are obviously lots of platforms and services out there you can use if you look into it, different observability providers, different data platforms. I'm sure you've heard of some of them. Not a sales pitch, as I said, so whatever you want to use, it should support these sorts of queries and data storage. So then how do we use this data? If we go back to the original table, we remember we have, okay, these are the raw results. These give us that sort of information. We have the one for availability. We have the one on performance. But now let's look at what a table could look like when we've actually applied these calculations to it. we end up with something like this. Say we take our flight search feature, and we've taken out the data, and we actually just view for each date, what was the availability, the page load performance, and the time to result on that day. This gives us a number out of 100, and it becomes a lot easier to understand. Again, if we think of visualizing this was our original graph where we were saying, well, how do we compare? Maybe should we be worried that the hotel search is higher than the flight search? Should we be worried that this is dropping or this is rising? But because the calculations we run also take into account sessions, which is really great, we can then start plotting graphs like this. I realized my colors didn't come out as clearly as I wanted, so apologies, but we actually start seeing like, you can then put this dotted red line, which is your SLO, and so you can see, were we above that dotted red line? In which case, great, there's nothing really to worry about. Have we dropped below it? Okay, we should be worrying. Is everything below it? We need to look into what's happening. And the same with actually putting this in a table. So looking at this, we could look back if we wanted to look back over, say, a 1 week or 1 month period. And very easy to understand. The green for a certain day is good, the red is bad. We could take a look at this and say, what happened on the 13th of October? Everything dropped, we can look into if there were any changes. Now, it is important to note we do have a Skyscanner proactive alerting on this, so you should too. This isn't just designed to be something retroactive, but it should be sort of part of your process of not only should you be getting the alerts, but you should also be able to historically look back at your data. This again becomes really powerful when you start seeing, thinking of companies saying, we had 99.59 or the 5 nines, 99.999% availability over the past year. And it comes from queries like this. And it's actually quite powerful to say, well, how available was our mobile app? How well was it performing? So what advantages does this really have? Again, going through it. So it's very easy to compare and visualize, as I said, and you also need no in-depth technical knowledge. Green is good, red is bad, is the graph above the line or below the line? It's very easy to take a very quick look. And you can know whether your drop is a cause for concern or not. And with this, you also still have all your raw data available. So as I said, if you're getting alerted on it, you get an alert that says your SLO has dropped and it's below it. You can still go in and view the raw data you had before, but it's just a lot easier to actually understand and look and know where to look and understand what's going on. And one of the other nice things we found as well is then you have the ability to change this per feature. We actually had a real example in Skyscanner. Well, we had one screen and we were tracking the page load and the time to first result, and it had to load a third-party SDK. And because it was loading this SDK, it had to take longer. It was rendering something on the screen. We knew there was nothing we could do about it. And we would always get the graphs and we'd get people saying, why is this feature always loading higher? Should we be concerned? And it actually got one of these really boring, every single session having to explain to someone new, oh no, it's because it loads this library, we know about it, it's nothing to worry about. But then you can also start falling into the trap of, if we start saying, oh, it's because of this library, we know about it, etc., we could actually see maybe a real increase that we actually caused, we actually did introduce a bug, but we're just saying, oh, it's the library, we don't care about it. And because we can define the SLI, for example, in this case, we said, okay, this screen has a higher SLI. So instead of maybe 500 milliseconds to load the page, it's 750. This then gives us exactly the same set of calculations, the same way of tracking these graphs, the same way of seeing the increases and decreases, and just really gives us that confidence. Now, the other thing which you might read a lot about if you do take a look into this SRE is it also gives you this really nice thing, what's called like an error budget or a performance budget, which is how many errors, or say unperformance sessions, but let's just focus on errors for now, do I have to work with before I breach my agreement? Now, I'm pretty sure everybody here as well has worked with some sort of migration project or some sort of release or new feature which you know is tricky and you maybe know it's not going to work on certain devices or old devices. And, again, it's, well, what does it mean? Can I have one, if it impacts one user, is that okay? What if I know it's going to crash for this specific device and so it's going to crash for 500 users? Do I need to care about that? Well, you should always care, but thinking of, is it acceptable or not? And actually, by looking at this, okay, well, if I have a 99.5% SLO, I can play with 0.5% of sessions. I can technically crash or have critical errors in, but still be within this. And so that's really powerful when you can start talking to other engineers, talking to maybe product owners of saying, look, we know this is going to have an impact. We know some users won't have a great experience, but for the 99.5%, it's going to be fine. It's still going to lead to these benefits of a migration. Those for 0.5% of users, they'll be fine once it's crashed once and the app has restarted and then everything's back in sync again. And that's, again, really, really helped us at Skyscanner. So another closing thought, just to go into this, is if you think those visualizations were powerful and really helping, just imagine when this is across all of your platforms. Because that's what we found. We actually, by scaling this out across like our backend services and our web services, as well as our apps, you can start, again, slicing this data however you want. And we then found looking at, okay, I introduced a backend change on this date. My backend change meant my backend availability dropped. That backend availability, the app availability and the web availability dropped on the same day. That's not good. Again, we should have an incident report, look at the impact of this. Being able to really correlate these changes has been really, really great for us. Just as what we're looking at next, as I said, this has sort of been a very, very long journey, which is still ongoing, and a lot to learn and a lot to go through. So we're actually looking at how we can link this with our A/B experimentation platform. Again, is really, really powerful. Am I impacting users with this test? What does this mean for the SLO adherence, for the errors, etc.? And we're actually still in the process of trying to shift left this observability, which means rather than having what you might have thought of as traditional sort of DevOps or SRE squad, by having this very easy for squads to maintain, have ownership over their own features, it should be something engineers enjoy. Maybe enjoy is too strong of a word. I don't know if engineers do enjoy this all of the time. But again, rather than feeling like a chore of saying, how do I need to monitor this data? Oh, great, I need to put a dashboard together. What does it mean? I'm just putting this together because somebody told me I needed to show these numbers and send it in a weekly report. Instead, it's actually this is really great. I can easily set up my definitions. I understand what it means, where the code's coming from, through the app, through the transformation, through to the dashboard, and what this actually means for my feature. If that does sound exciting, then had to put the slide on. We are hiring at Skyscanner. Please come have a chat to me afterwards if it's interesting or you just want to learn more. And yeah, that's it for me. Thank you very much for your time.